Okay, I think it's about time. Hi, welcome back. Thank you. That's the spirit. So, how many of you have been to my talk this morning about the ASP.NET Core stuff? Okay, most of you. And how many of you are building server-side applications? And client-side, like on devices, in the browser, and so on? Okay. So, traditionally, I've been mostly all my life interested in the server, right? And that's the reason why I have this open source project called Identity Server and so on. So my main life happens on the server. But obviously, the only reason you have a server is because you want to build clients, right? that's probably the main motivation for that. So in my daily work, I spend a lot of time working with customers and working with them together and discussing how they should build their clients and what types of clients they're building and what the gotchas are and so on. And obviously, the main reason they ask me is because they want to build clients for like token-based systems like OpenID Connect and OAuth-based systems and so on. And that's basically what I'm doing every day. So this talk. So when I wrote down the abstract for this talk, it was very ambitious. Yeah, let's have a look at all the client types you can build and and so on. And then I start putting together the slides, and I realized I have 43 slides for 60 minutes. So I hope we can pay enough attention to every little detail here. This is not an introduction to OAuth and OpenID Connect. My assumption must be that you at least know some of the basics and the protocols, and like maybe have a little bit of practical experience already, because it's a lot of stuff, and I can't just fill in the basics here. We just did a 2-day workshop, and this part here took us at least half a day in the workshop. So that's like the compressed version of it now, like quick speed learning, if you like. Okay, so. Let's get started. My name is Dominic. I already uploaded the slide deck to speakerdeck.com, so you can download it from there. I have put a lot of links to further reading material into the slides, because, as I said, after 60 minutes, you probably have more questions than before. So, like give you a little bit more what you can, read up on if you want to learn more about these things. So, what are the objectives of the talk? I want to basically discuss like the common challenges you will face for building a client for an OAuth or an OpenID Connect based system. And it turns out these challenges are always the same regardless what type of client you're building. But then once you're building a very specific client, obviously every client type has other little gotchas and things to look out for. The good news is, if you haven't, started reading up on these things and it was very confusing, it's getting easier. Okay, there are new specs out there, new guidances out there, especially in the world of when you're building JavaScript-based applications. Things actually get easier. That's the good news. Okay, they are basically consolidating some of the guidance that was before a bit fragmented into more digestible documents, and I think we are on a good way of making this accessible to mere mortals, I think. Yeah. Okay, so why is it so hard actually to learn about these things? Yeah, and the answer is because it's complicated. Yeah. So historically, there are two big standards bodies out there on the internet that take care of these standards. On one hand, there's the IETF, right, that published this thing called RFCs, and OAuth, for example, is an IETF standard. But then you learn somewhere that OAuth is only half of the story. You also need to learn OpenID Connect, and suddenly you figure out, well, that's a totally different company taking care of. Yeah, that's the so-called OpenID Foundation. And in my personal opinion, what they should do is they should merge, because these topics belong so closely together that there shouldn't be fragmented guidance that you have to look up on two websites. But this is, I guess, also something political, and this will not happen anytime soon. But if you wanna just have a look at what's out there, these are the two websites you should have a look at. Okay. And that's probably really bad guidance, because afterwards you will be even more confused. So I tried to take all these specs that exist on both and put them into a context. And it took me quite a while, and that's how that looks like. Okay, so there's a substantial number of specifications out there. And you know, not everyone here is probably working full-time in security. I do, so I think I read them all. Yeah. And I recently heard someone saying he counted all the pages of all the specs, and it's double the number of War and Peace. Okay, so it's a lot. So what I'm trying to do now is kind of sort these things, may make it more easy for you to, you know, to figure out what's important and what's not so important. Okay, so basically, you know, when we look at the typical architecture picture, that's the picture I'm always showing here. We see some servers, we see some clients here, and we see servers that become clients, right? And in the OAuth world, you basically make a distinction between so-called public clients and confidential clients. And the definition in the spec, what a confidential client is it basically says a client that can securely store a secret. Okay. And what that means in English is it's typically something that is deployed on a server, like on a trusted machine, right? Something that runs in your data center, maybe something that, you know, some process that is running at a business partner that, you know, have some trust in, and so on. And you know, and the opposite of that is basically a client who can't store a secret. And these are typically things like, you know, running on in browsers, running on mobile phones, running on desktop computers, right? Basically deployed outside of your control. And obviously there is no point in having a secret, because how would you deploy this secret? Probably not in the source code, probably not, you know, in a config file, whatever. It's not really a secret. So we have to deal with these two client types in a different way. Yeah. So let's start with the confidential ones, because they are easier actually, because we have the luxury of, you know, being deployed on some trustworthy, you know, hardware or on a server or in a data center, whatever. Anyways, regardless, first of all, the challenges for building a client, they look easy to start with, right? It's a token-based system, so you want to interact with that. You request a token, you use the token. That's it, right? So let's have a look at how you request the token, and this is the so-called OAuth client credential flow, and this is the approach you would use if you're doing like a server-to-server style communication, right? You know, like one server talks to another server. They, you know, the connection must be authenticated and so on. And this is very easy, right? So the client goes to the token service. It authenticates with the token service. It has a client secret. It's a confidential client, so this secret is stored somewhere securely. Right? It says, okay, give me a token for this API. The authorization server will authenticate the client, make sure that this client has access to the APIs he's asking for, and send back the access token, and then the client will use that access token, right? These are the two fundamental steps: request the token, use the token. So using the token is also easy. You typically just take this token that you got from the token server, you put it on the authorization header of your HTTP call. You should use the authorization header. It has a special meaning in HTTP. It is a dedicated header for storing confidential or transmitting confidential stuff like credentials, for example. They typically don't show up in log files, right? And so on. There's actually an extra spec for that just talks about how you should transmit tokens, and that's RFC 6750. They also have alternative means of transmitting this token. They talk about query strings and as a buddy payload data. These are all, you know, alternatives if you can always use the authorization header. Okay. And then the interesting part starts, token management. Okay, so requesting a token is easy, using a token is easy, but what do you do in between? Right? Tokens need to be stored somewhere. So you need to make a decision, where do I want to store my token? Like, is it in memory? Do I use a distributed cache maybe because I have so many clients and, you know, you want to share these tokens between the clients? And even more interesting is how do you deal with token expiration? Right? So tokens typically have finite lifetimes. Okay, so you get a token, it's valid for an hour, 30 minutes, 10 minutes, whatever, right? You have to design all of your client applications in a way that they can deal with the fact that the token has expired. Yeah? There are two fundamental approaches to do this lifetime management. One is what I call proactive. That's the one I often use. Is basically you have some sort of caching system, okay? And that could be in memory, that could be distributed. So you get the token, it's valid for 60 minutes, you put it in the cache and put a cache lifetime of 59 minutes on it, okay? And then whenever you need the token, you get it from the cache, and if it's there, you use it. When the token is gone from the cache, that means it's probably expiring very soon, so you get a new token, put it in the cache again, reuse, or you use that new token. Yeah? Reactive is another approach that some libraries use. Basically, they don't use caching or something like this. They just use the token, use it, until you get a 401 back from the API. And the 401 typically means your token is not good anymore. And what you then do is you lazily get a new token and resend the request. Okay, so these are two approaches that are often being used. Now, so when we have that in mind, the challenges are a little bit more, right? Requesting the token means, okay, which protocol flow to use? We just looked at client credentials and there are more. Is a user involved? When a user is involved, then typically it's more complicated because you can't just simply do server-to-server API calls, you have to involve UIs. Yeah? Managing the token, where do I store the token? Yeah? How do I renew that token? Yeah? Do I require long-lived access to this token? Meaning, does the client application maybe require access to the API after the user has left, right? Like maybe it's a web application, the user has shut down his computer, but still in the background, you're still having to process some data on behalf of the user. So you have to extend basically the token beyond the lifetime of the user session, so to speak, yeah? So let's have a look at user-centric clients, because that's where typically things become a little bit more, some say interesting, some say complicated, yeah? Depends how much you enjoy these technologies. So when you're building like a user-based, like a UI, okay? You typically have more concerns than just having a token to call an API. You want to authenticate the user first, right? And that requires typically some sort of login workflow, right? In a browser, for example, you show a login page and he might choose to log in with an external authentication provider, and there might be some redirects involved and so on. But ultimately, typically, this authentication will result in either you start a new session for this user, or you're joining an existing session. Yeah? Think of single sign-on. Maybe this user is already logged onto a different application, and then you want to join that single sign-on session so you can give that user a single sign-on experience. Yeah? Once that is done, you also want to have an access token to call APIs on behalf of that currently logged on user. And then, and that would be nice if from that point on you don't have to bother that user anymore with any security related things, right? You have the access token, but if this token expires, there must be some way how to get a new access token without having to bother the user again and again and again, okay? As I said this morning, the best security systems are the ones that are for large parts out of the way of the user, okay? So OAuth has this thing called the authorization code flow. That's maybe the mother of all OAuth flows, the one that first got created. And let me quickly show you how that works as a refresher, hopefully. The idea is you are in, let's say, in this case, a web application. The user starts to use the application. You have to log him in. You want an access token. Basically, you are firing off a redirect to the token service. You are using, in this case, OpenID Connect to authenticate the user, to get some tokens. Basically, you say here, okay, I want to know who the user is. I need his email address, and I need access to API 1 and API 2. And offline access means I want to have a token that I can renew myself without having to involve the user again. And the word code flow comes from this response type, which is called code. Okay, so what the server will do is if everything is fine, the user is authenticated, and so on and so forth, the token service will send back a so-called authorization code to the server. This code is just a random number, right? It has no meaning whatsoever. But once the client application has this code, it can open a server-to-server back-channel communication, send that code in, authenticate with the token service, because it's a confidential client, we can authenticate with the token service, and then the token service will send back all the tokens needed. And you typically get back 3 tokens. The identity token is the token for the front end, which has the information about like the user ID and maybe his display name and things like that, and also authentication details. The access token is the thing you're going to use later on to talk to the APIs. And the refresh token will be the thing that allows you to get new access tokens programmatically once the old access token has expired. Okay? So that is widely deployed. Many websites out there are using CodeFlow. Yeah? But there are some issues with CodeFlow. And the whole reason they invented CodeFlow in the first place is to not leak any data over the front channel, over the browser, right? The browser is considered to be the weakest link in our chain. Yeah, that's the thing on the user's machine. It might sit in like a hacked Starbucks Wi-Fi network, whatever. So if an attacker could steal that code from the browser or from the Wi-Fi where it's being transmitted, there's nothing the attacker can do because he still is missing the client's secret to turn this code into the actual access token, right? That's why code, many people think that's the most secure way of doing it. There is one weakness in CodeFlow, and that is called token substitution attacks. And the idea is this: if an attacker can somehow steal a code, maybe he can trick you to log into a malicious web application, and then the token server will send back a code representing you, and the attacker can steal that code, for example, and then can take this code, go to the application, log in, and on the way back exchange his code with your code, right? You're tricking the server, the client, into using his secret to turn the stolen code into tokens, and now you can basically impersonate that victim, that user, using just the legitimate application, right? Because we basically cheated, okay? This is a problem because basically there's no way to protect against it in OAuth, in pure OAuth, yeah? So that's why there are a couple of mitigation techniques out there. The first mitigation technique comes, and is older, to be honest, comes from OpenID Connect. Yeah? So OpenID Connect, when they designed OpenID Connect, and OpenID Connect is an extension to OAuth, yeah, to make it more secure, I guess, and also to constrain some of the possibilities you have to make it more interoperable. The OpenID Connect guys introduced digital signatures to solve the problem. Okay, so we'll talk about this first, and then I'm going to show you the other one, which is also used in many situations. So when you look at the solution that OpenID Connect has to the token substitution problem, what they do is basically this: when you are requesting or doing the authentication request, you are asking for 2 things. The code, just like before, but an additional identity token. And what the identity token is a signed data structure coming from the token service. And this data structure has information again, like who is the user and how did he log in and more things. But it has something else in there. It has a special claim called the C-hash claim. And what the C-hash claim is the hash of the code. Okay, so when you now get the identity token, you can validate the signature on the identity token with the public key material from your token service. Once you have that done, you get the C-hash claim, then you get the code, you hash the code, you compare the 2 values, then you know that this code actually belongs to the currently logged on user and is not something that somebody tries to play games on you. Okay? That's how OpenID Connect solves the problem. And for example, this is, for example, fully implemented in ASP.NET Core. Okay, so if you're building an ASP.NET Core application, the built-in OpenID Connect handler fully supports hybrid flow. All of the complicated crypto stuff, you don't need to know about these things. It's all being handled internally. Yeah, the handler does the back-channel communication. It does the authentication with the server. It does the hashing. It does the signature validations, and so on and so forth. Okay. Let me quickly show you that. So. Oh, by the way, all the samples here, they are, I have a link for them on the last slide, so you don't, you can try them out yourself. Okay, so that would be an ASP.NET Core application that is using token-based authentication, and the typical recommendation is you are using the OpenID Connect handler from Microsoft. That's this guy. And then you see you're pointing to your trustworthy token service. You see here the response type is code ID token, so that's hybrid flow. Okay, that signals the authentication handler that he has to do all the extra work to protect yourself against token substitution, and then you specify some other things like which scopes do you want to request and so on and so forth. Okay, when we run that, it's, as I said this morning, it's mostly invisible because all the stuff is happening internally. But basically, the user goes here, he logs in. If it's the first time he's logging in, he probably gets a consent screen or not, depending how you configure this thing, telling the user what information he's about to release to the client application. That depends on your business, if you want to do it or not. And you see now that the user is signed in, and here we have the access token. Okay, so that's the first part of the story. And now, as I said, requesting the token, relatively easy. Using the token, relatively easy. All you need to do now is create an HTTP client, set the authorization header, call the API. That's how it works. The tricky part, obviously, is now managing the token again. Yeah. So we need to store that token somewhere, and we need to manage the lifetime of the token. So in ASP.NET Core, you have multiple options of doing that. Yeah. So the handler itself has an eventing model, so you can implement various events here that get called at various stages. They hand you over the tokens in a validated state, so to speak. And now you could just go to a database and store them somewhere so that you can access them anytime you want. Microsoft has a built-in feature. I showed that this morning already. Which automatically saves the tokens for you in what they call the authentication session, okay? And that's why we can also see it here on this page. I'm just reading from the current authentication session, and that's where my code would grab that token from every time it's needed, okay? I also showed this morning that you can plug in some extra stuff into your session management to do automatic renewal of the token. So basically, here's an event called validate principal. This gets fired every time a user, a cookie comes in or a request comes into your web app, and then you can look at the current access token, can check the expiration of the current access token, and if it's about to expire, maybe you have some threshold, yeah, like 5 minutes before or 1 minute before, whatever. Then you basically open a back channel communication and then get a new token, and then you update the token value in the session. And again, your application code will just use that and can be unaware of the technical details here. Okay? And the other nice thing you can do is, if you want to do that, I mentioned earlier, sometimes you might need API access after the user has signed out from your application because you want to run some scheduled tasks or batch jobs or whatever. Then obviously you would keep that refresh token around for later use whenever you need it. But in many situations, when the user is actually signing out from your application, you want to clean up all the tokens that you accumulated. And there's another event here that is fired basically at sign out time. And then you can, if your token service supports that, just revoke that refresh token and invalidate it. So even if somebody would steal it now, it would be worthless. So that's a clean implementation, in my opinion, for ASP.NET Core. Okay. ASP.NET Core, I must say, I mean, I'm spending a lot of time in ASP.NET Core. Is a pretty good and complete implementation of an OpenID Connect and OAuth client. Yeah, I've seen other programming environments that are by far not as feature-rich as what you get in ASP.NET Core. I recently had to do an integration with PHP, not me myself, thank God, but just help someone doing that, and they have by no means these really good libraries. You have to do a lot of things by hand. Okay, so in other words, if you are having a system that supports hybrid flow, that's good to use. Okay. there are some issues with hybrid flow as well. And the main issue is that it's not widely adopted. I just mentioned that, right? With PHP, for example, there was no hybrid flow implementation available. I haven't looked or haven't made a comprehensive study of all the platforms, but the reason why many people didn't implement hybrid flow is because it's actually quite complicated, right? You have to do all this crypto, verifying signatures, hashing, you know, a lot of things, yeah? That's why many platforms just stayed on plain code flow and just ignored or are not aware of the problem with token substitution, yeah? The other thing that comes up with hybrid flow, and funnily enough, OpenID Connect was created before GDPR, yeah, is that when you are sending this identity token on the front channel, you are potentially leaking identity information over the browser, okay? And even if that identity token only contains the user ID, yeah, depending on your GDPR consultant, this might be considered personally identifiable information. Yeah? So the nice thing about the code flow, like in its raw form, is that it doesn't leak anything across the front channel, just this random number, and everything else is happening on the back channel. Hybrid flow solves the substitution problem, but you are getting this thing here, which might or might not be an issue. Your subject ID, your user ID shouldn't be anything personally identifiable. It's just a number, right? It's a user ID, yeah? But if you're adding more stuff to it, like email addresses and stuff, and then potentially somebody might flag that because you are sending this over the browser channel, and that might not be okay, yeah? Let's switch gears and go to public clients. And while we do that, I will also demonstrate to you the other mitigation technique for token substitution. Public clients, as I said, they are clients which are deployed on devices and in browsers and so on. And you know, normally for confidential clients, you have a one-to-one relationship between your client IDs and your client instance, right? You have your app 1 and your app 2 and your app 3 and so on. They are basically records in your configuration database. Each of them have their own unique secret and so on, yeah? For public clients, it is very common that you just give that client type a client ID, right? So you write a mobile client, you call it mobile client, you put it in the App Store, and 5 million people download the mobile client, they're all going to share the client ID, right? There will be no secret because, as I said, there's no point in having a secret. And for most parts, this is okay. In some scenarios, you can use an additional technique called dynamic registration. And the idea is that, let's say you write your mobile client, you give it like a bootstrap client ID called mobile client, you put it in the App Store, and the first time it's being run on a user's device, you start some additional authentication handshake and then register the client instance dynamically, right? And then you will get back from the server a new client ID and a client secret, and that's how you effectively can turn a public client into a confidential client, if that's a requirement. But keep in mind, this initial bootstrapping infrastructure must be created, yeah? And there's no spec for that or whatever. It's basically something that you have to build into your system, okay? As an example for a public client, let's start with an easy one, which is native mobile clients. The good news is that I think like 1 year ago or so, there's a new spec out there called OAuth 2 for native applications. It's written by the IETF. You can tell because they use the word OAuth 2 here. If it would have been written by the OpenID Foundation, it would be called OpenID Connect for native applications. Yeah? Funnily enough, the guy that wrote the spec, he also made reference implementations of the spec for both iOS and Android. And guess what he's using? He's using OpenID Connect, not OAuth. Okay, and guess where these samples are hosted? On the OpenID Foundation GitHub website. So it's all, you know, our life could be much easier if these two, organizations would just say, okay, let's join forces. But yeah, okay. This spec here is not a protocol. It's what they call a best current practice. Okay. And good, they have the word current in there because obviously they change probably over time, but it's pretty new, and everything that's in there totally applies to today. Okay, And this is more like a guidance document, like about patterns and anti-patterns and do's and don'ts and typical approaches. And they actually really specifically look at iOS and Android devices, how you would do that, for example, also at desktop, Windows, and Mac, and so on, and give you some guidance. Yeah? So one of the guidance they give is, don't do this. What is this? This is basically a mobile application bringing up its own native login dialog. Yeah? We all know these. Yeah? Companies want us to use good passwords, and then they force us to type them in on the mobile device into a native dialog. Yeah? It's a bit of a usability thing. In OAuth, there's a flow called the resource owner password flow, and the idea is basically, you're harvesting the credentials here, you're sending them to the token service validates the credentials, sends back a token, hopefully then you store the token in the secure data storage API available on the device, and then from that point on you use the token, okay? I mean, that's not too bad. I mean, it's much better compared to, applications I've seen where they send the name and the password on every single API call. Okay, so at least you exchange the token, the password at some point into a token, and hopefully you threw away the password. Yeah? The problem is when I see these applications with these native login dialogues, I never know, are they really throwing away my password? Or are they keeping it around somewhere? Yeah? And there's a trick you can do. Well, it's not really fun, but I discovered by accident, yeah. So I got a new iPhone. I did a backup of my iPhone, and when you back up your iPhone, you have to do two backups, right? One is the application backup, and one is the keychain backup, right? The assumption is that all of the secrets, like passwords and tokens and so on, they are only stored in the keychain and not in the application space. Yeah. So I did that. And I restored the backup on my new phone and just thought, okay, so in theory, all my applications are back now and I should be logged out from all of them, right? Because I haven't yet restored the keychain. Guess what happened? I was logged into many of them. Why? Because they probably stored my password just in their application directory. Okay? So, yeah, not so nice. So yes, there's a trust issue here, at least for me. The usability just got a little bit better in iOS 12. They now enable password managers for native login dialogues. That's quite nice, actually. But still, from a user education point of view, you shouldn't educate your users to type in their passwords in random places, right? It would be good if the login page always looks the same. It's always in the same place, and probably when you are concentrating on one single login page in the organization, the chances are that this thing is much smarter, right? You have your auditing and your logging and maybe your fraud detection and your logout and all the things that you probably would implement there. But if every application developer creates its own login page, how good will that be? I don't know. The other thing is obviously you can't do federation here, because if you want to support things like Google logins or I don't know, business-to-business style logins, you can't do them because they require a browser. And obviously the one thing you don't want to do is ask your user for his Google password in your application, right? So, long story short, the guidance says if you're building a native application, you should use a browser for authentication. Okay, and many people don't like that, especially the guys from the UI department, often, or the UX department, even worse, I guess. They have objections to that because they don't have full control over this. They can't control every pixel, right? But from a security point of view, it makes a lot of sense, yeah? You already have this login system, yeah? You already have existing investments into your OpenID Connect server, for example. So the best thing to do is just spawn a browser, go to the login page you already have, make the user authenticate there, and then there are ways to basically transfer the tokens back to your native client, okay? Before I show you actually how that works, I can show you how it looks, okay? That's my second favorite version of Visual Studio. And for some reason I have two iPhones. I don't know why. And from all the things, one is an iPhone 7. But basically, let me just show you how that login workflow could look like on a mobile device. once it's up. Okay? So, see my very nice UI design. So, there are a couple of choices when it comes to opening a browser in these native application development systems. One is what they call a web view. Basically, you embed a browser into the application, right, without all the Chrome around it, so to speak. This is not recommended at all. Yeah, the user can't tell, am I really in a browser or just something that looks like my login page? Yeah, you can't see the URL, you can't inspect certificates properly, and so on and so forth. But also, even more important, this will have its own isolated cookie container. Meaning, if you want to support single sign-on in the native world, then this wouldn't work, right? But if you would spawn the system browser on the device, chances are that the user might already be logged on in the browser with that service that he wants to use. Google, for example, or whatever. And in that case, you could reuse an existing single sign-on session that already exists on the device. Okay, so Apple gives you special APIs and Android as well to open and they call it like a custom tab. Basically, think of it as opening a tab of the system browser inside your application. It is the real system browser. In that case, Safari. You have access to all the cookies that the normal Safari would have. Yeah, and it's hardened in a way that you wouldn't be able to log keystrokes and things from within the originating application. Okay, because this is a very special browser, Apple will insert a little dialogue here saying, "Hey, be careful! You are now going to sign in somewhere, regardless of what the app just said you're going to do." Okay, and it will show you the name of the application on the screen, and it will show you the name of the server that you're going to authenticate with. So if you're okay with that, you click continue. Then it will render a login page. Okay, so I see I have multiple options here, name and password and so on. They also allow Google logins, and I'm already logged onto Google on my device, so maybe I can just reuse that authentication session. And here we are. That worked. No login page from Google. That's my consent screen. I allow that, and now my access token and my refresh token and my claims are back in the client application. And now you know the drill, right? You store the refresh token somewhere secure, and whenever you need to renew the token, you take the refresh token, open a connection, get a new access token, and use that. Okay? You should store that refresh token in the keychain. I hope I made that clear. Some applications to put additional things on top, where you can put stuff into the keychain and then additionally secure that item with, let's say, your fingerprint or your Face ID, for example. So my banking app does that, for example. So every time I open the banking app, I first have to do Face ID. That unlocks the keys in the keychain, and then they use that to access the banking APIs. Okay? So how does it work? So there are a couple of approaches here, but typically what you do is you register a so-called custom URI scheme. So basically when you install the application on the device, you can say, okay, this URL belongs to me. And the recommendation is that this URL contains your company name, so you can actually claim that this is really belonging to the application. And then the operating system knows about that, and whenever the system browser makes a redirect to this URL, it will transfer control back to the application that has registered for this URL. And it will basically send you the code. Okay? So in this case, the code is coming back, and then the Safari will call back into the native application, and we have the code. Then we can open the back channel communication, and we have our tokens. Okay. So for those who have looked closely, you will see that there are some extra parameters that you might haven't seen before. And that is the other mitigation technique for code substitution. It's called PKCE, or proof key for code exchange. That's another spec from the IETF, yeah? So it's for OAuth, which is silly. But the idea is this. It solves the exact same problem as the hybrid flow by preventing code substitution. How does that work? Let's go a couple of steps back here. You can see basically you are creating a so-called code verifier. That's a random number. The client creates a random number called code verifier. Then the client hashes that random number and sends that along and calls it the code challenge. Okay? Now on the server side, the token service will associate the code challenge with the code that he will emit. And then when you open the back channel communication, you are sending the clear text code verifier to the token endpoint. So what happens then is, on the server side, the server will take the code verifier, will hash it again, and will compare the hash he got on the front channel with the hash he got on the back channel, and that's how the client can prove that he basically is the same client on both legs. Okay? And if somebody would substitute a code now, this hashing would fail, and you have exactly the same end result. The substitution wouldn't work anymore. Okay? Now, which one is better? Well, they are very similar, right? I mean, they have the same end result. The reason why people prefer Pixie these days is because all of the hard crypto work is happening on the server and not on the client. Okay, so it's easier to create client libraries because you don't have to pull in crypto libraries and do hashing and signature validation and so on. All you need to do is basically have a random number generator and a hash, and then all of the harder stuff is basically happening on the server side, and that's why my prediction will be that this will be the more prevalent approach in the future. And if your token service supports Pixie, I would recommend you're using that. It's very easy to use. Okay, yeah, token management. I mentioned that you should leverage the secure data storage APIs you have on the device. The keychain on iOS. On Windows we have DP API, the data protection API. Same idea. You can put on additional biometrics, for example. And so on and so forth. Yeah. Again, same idea. Maybe at logout time or at uninstall time, you want to revoke all these refresh tokens that you have accumulated here, just to be clean. Yeah. I can show you another application that uses the same approach. There's the GitHub desktop client. Okay, whatever that means. So when I sign in to the GitHub desktop client, you see basically I press the sign in button. It says, okay, you want to sign in with your browser? Because chances are that if you are using GitHub, you already have a GitHub authentication session on that machine. So it will pop up the browser. I'm authenticated. I say, okay, that's fine. Let's go back. And now I'm signed into the client. Now, same idea, native client, leveraging the system browser to do its work. Okay. Now, oh yeah. Here are the client libraries. The upper ones are the native ones, and you see there from the OpenID Foundation, funnily enough. The lower ones are the ones I wrote that you just saw in the iOS app. It's a C# library which works on multiple platforms. So, the big elephant in the room, yeah, is browser-based clients, SPAs. Yeah? Traditionally, SPAs are really hard to secure because they are running in a shared execution environment, right? The browser runs multiple applications at the same time from different domains, and they have varying degree of trust, okay? And because we are sharing, so to speak, one virtual machine with multiple applications, there are all kinds of attacks which are browser specific, and they all have the word cross in there because you're crossing, so to speak, a domain or a boundary. Yeah, cross-site request forgery, cross-site scripting, and so on. We were discussing this for a long time, that we need actually something similar to OAuth for native apps. It would be nice if somebody would create OAuth for SPAs. Yeah, because it's hard, and it would be nice to have a clear document with guidance. Do this, don't do this. That's the recommended approach. They were punting on that for quite a while because it's a complicated topic. But now finally, just a couple of months ago, the work has started on OAuth for browser-based apps, and you can track the status here. They are currently on the second or third draft. That's good. Okay, so. Browser-based applications historically had a number of issues. Like back in the days, people used cookies to secure their AJAX calls. This had cross-site request forgery problems. You can mitigate against cross-site request forgery attacks, but that requires extra work. You have to implement basically anti-forgery, some kind of anti-forgery measures. Yeah. And in my years of code reviews, I often have seen that people just didn't do it. Okay, so potentially cross-site request forgery. So with that background, the OAuth or the IETF thought, let's improve that situation with OAuth. Okay, so when we can create a profile for OAuth that works in the browser, we don't need cookies anymore and can use access tokens instead to secure our APIs. Okay. And as you can see, in 2011, it wasn't clear to everyone on the IETF why you would ever write an application in JavaScript. Yeah, that's a screenshot from the original mail archives. Yeah, but you know, the work started in 2012. They released this thing called the Implicit Flow. You might have heard of that. Yeah, and imagine, it's 2012, so they had to create something that worked in browsers in 2012. Yeah? And the code flow that was already existing, you know, they could have used that, but that requires AJAX calls, the back-channel communication, right? And in 2012, there was no legal way of doing cross-domain AJAX calls. CORS didn't exist yet, okay? So they came up with this implicit flow, basically, where they transport the tokens over the URL, okay? And you know, no one was really happy with that, but that was, at least there was some existing guidance out there that there were threat models around it, so if you read the threat model, you knew, okay, these are the issues you have to mitigate, but essentially people didn't like the fact that these tokens are on the URL, for example. There were implementation faults that led to token leakage in the past. They end up in the browser history, right? Because it's a URL. Again, you could work around that and so on and so forth. But all in all, the implicit flow was never like the most favorite flow in OAuth. Okay. Just recently, the discussion has started again, and the decision has been made. And maybe you have heard about that, or maybe not. And you should know about it, is now in 2019, cross-domain AJAX calls are a solved problem, right? We have CORS, it's working, so it's time to deprecate the implicit flow, okay? There was a very, very populistic blog post recently where somebody described it as every application using implicit flow is now vulnerable to some sort of attack. That's not true. Okay, so if you have an application out there that uses implicit flow and you have used all the best practices and the mitigation techniques and everything, you don't have a new problem. You just have the existing one. Okay, if you are, so in other words, you are not insecurer than 4 weeks ago. Okay, but if you write a new application today, then I wouldn't recommend that you use the implicit flow again. You would say, let's go to code flow with Pixie instead. So using the exact same flow that native is using, and the exact same flow that you would probably also use on the server side if you have an implementation of that supports it. And the side effect of that is, you know, one of the things that my customers are struggling the most is when they read all these specs, they see, oh, there were 5 flows defined in OAuth. Which one do I use for which application type? Yeah? And with this new guidance, it basically goes down to 2 flows. Client credential flow for server to server, and code flow with Pixie for all the other application types. Okay, and I think that is actually helpful. Okay, but the problem doesn't end with the OAuth flow, right? Getting the token into the browser is one thing. Now you have to store that token in the browser as well, and also, you know, manage it, yeah? And that's where actually the real trouble starts, yeah? So there is no secure data storage mechanism in a browser. Wherever you store it, if you have a cross-site scripting attack in your client application, there's a potential that the attacker can exfiltrate those tokens from your session storage, your local storage, your IndexedDB, wherever you store it, right? And that means now that you potentially have high-powered tokens in your browser, and an unknown cross-site scripting vulnerability that you are not aware of allows an attacker to steal them. Okay? You might say, isn't cross-site scripting a solved problem? It's not. Okay? Many frameworks have still cross-site scripting problems. There is actually a thing called Content Security Policy, CSP, which is specifically made to mitigate against cross-site scripting. So how many of you in the audience actually heard of CSP before? And how many are using it? Okay, a couple of you. That's good. CSP is the right way to go. I thought, at least, until I had a discussion with some people from the OWASP team recently, and they pointed me to this video. So whoever is using CSP, please watch that video. Oh, well, actually, everybody watch that video. Okay? It's a video from some researchers from Google, right? And they spidered the internet. I think Google has the technology for doing that, yeah? And they found, in total, 1.6 million websites with content security policy enabled, which is not a lot, right? And from these 1.6 million, they were able to bypass 90% of them. Okay? And what's the bottom line here? CSP is too complicated. Okay? For all of you that have used it, you probably know what I'm talking about. You have to know a lot of things about CSP to apply it correctly. They found many websites, for example, that load their, let's say, jQuery or whatever from some CDN. So they whitelisted the CDN as a legal script source, for example. What these guys found out is if this CDN has a single JSON-P endpoint enabled, then you can abuse that whitelisted endpoint to smuggle in script from a third party into your application and then do cross-site scripting again. Yeah, so there are some subtleties here. This is a really good video. It not only shows you how to bypass it, it also gives you tips how to harden your CSP as well. And in my opinion, CSP is still the one thing you should definitely learn about. How many of you have heard of HTTP token binding? A couple of you? So that was a very, very promising technology that allowed you to bind tokens to a browser, okay? More technically to a TLS connection, but the end result would have been if somebody can actually steal a token via XSS from your browser, he can't use it because the token is worthless outside that specific browser, okay? Because there is some extra crypto stuff that you don't have access to from JavaScript. Okay? Guess what happened? Google, after token binding has been ratified as an official RFC, Google decided to not implement it. And that's pretty much end of story, right? I mean, such a standard is so useful, but is so useless if not every browser vendor implements it, right? Because now suddenly it depends on the browser if you are secure or not, and Chrome has kind of like a bit of a market share. Yeah, so long story short, XSS is still the public enemy number one, okay? So, we are working on a JavaScript client library. We have switched after all of that guidance has been updated. We have switched to support code flow as well. So if you're using our library, which is called OIDC client.js, all you have to do is change the response type from ID token to code, and that's it. The rest of your application can stay the same. Okay? If you have done your own implementations, you have to figure out what to do. The last thing I want to make you aware of, if you are not yet, is called same-site cookies. Yeah, that's a rather newish addition to the W3C specs. And the reason why we went to tokens in the first place was cross-site request forgery, right? And now tokens have the XSS problem. Yeah, so what would be really helpful is if we could get first rid of cross-site request forgery. Yeah. That was historically not easy, but now there's this thing called same-site cookies. And the idea behind same-site cookies is that you can basically, when you issue a cookie, you can instruct the browser to only send that cookie back if you are on a page that came from the origin that issued the cookie in the first place. Okay? And you wonder, why hasn't this been done 5 years ago? Yeah, or even earlier. Okay? So, basically, same-site cookies can prevent all cross-origin usage of cookies. Okay, and that's the thing that brought us to tokens in the first place. So you could actually you could add additional hardening on your applications by turning on the same-site flags as well. Okay, you have to be careful. There are two settings. One is called strict and one is called lax. Strict probably will break most of applications if you haven't designed for it because it's very, well, strict. Yeah. Lax means the browser will prevent all sorts of posting cookies cross-domain, which is the main problem really, yeah? Doing posts, yeah? Get is not the main problem here. As you can see, it is actually really well supported already, yeah? By all of the current big browsers, okay? My only concern is obviously that it's only on the latest versions so far. Yeah, so for example, you see here iOS, Safari. If you go like one version back to 11, they don't support it. Same for the Safari on macOS. But you know, Edge and Chrome and Firefox and so on, they support that for quite a while now. Yeah? So I can't give you, unfortunately, I can't give you the one true solution to your SPA problem. Well, actually, I can. Fix cross-site scripting, right? Because that's the root of all evil here. Yeah? Some of my customers said, like, this is all madness, yeah? We throw more and more JavaScript at the thing and more JavaScript and more, and we still don't solve the XSS problem. So they came up with this architecture here, which some people call the BFF architecture, yeah? Back end for front end. And the idea is that you actually store all your tokens on the server. So you don't even store them in the browser. Okay? And whenever you want to call an API, the front end basically uses a same-site cookie or maybe anti-forgery to call the server. Then the server attaches the access token and makes a server-to-server call in the back end to talk to the actual API. Okay? Is that the silver bullet? What do you think? No, it isn't, right? I mean, still, if you have a cross-site scripting vulnerability here, then somebody can make the client call the BFF, and the BFF calls the backend API. Yeah, it's just a different threat model, I think. Yeah, some people might be more comfortable with doing stuff server-side. Some people might be more comfortable doing stuff on the client side, but there's still no excuse for not fixing your cross-site scripting problems. Yeah. So yes, that's the situation right now. Do we have time? Yes, 3 minutes. Are there any questions on that? It's a lot of material, and I had to run through that quite quickly because it's a lot of material. But I hope you have an overview now, and this is a good list of further reading if you want to learn more about, you know, the specific type of client that you have to write. Yes?
You said that the implicit flow is deprecated for single patch. I heard that, but then you said the PKCE is the way to go. But I think I read about a lot of other flows which are recommended for single patch as well.
So the question is, so I mean, so the question is, I don't even know what the question is, but so the answer is officially the IETF is planning to deprecate the implicit flow. Okay, that is in its very early stages, and I think a lot of the details have to be figured out yet. What are the alternatives? Okay, but the immediate alternative is use code plus Pixie. It is actually more secure is a wrong word here, but it's nicer in the sense of that you can hide your tokens better from the front end. But as you just learned, to be honest, in my opinion, the the way you bring that token into the front end, yes, that's one part of the story, but I think the token storage problem is the much more interesting one. Yeah. I don't know about the Microsoft guidance, to be honest, yeah, but yeah.
If we're implementing a public client like a SPA and we use the code with Pixie,
Yep.
do we need a client secret? Is it
No. Yes, so the question is, do we need a client secret for a public client? No. You never needed it, right? And that doesn't change anything here. Public clients don't need client secrets because they are not secret. I mean, especially in JavaScript, where would you put them, right? And Pixie is specifically designed to support public clients. Any other question? Yes?
You said Pixie was preferred because there was no cryptography on the client, but it looks like the code challenge is a hash.
Yes.
Which means that it has to be hash
Yes.
Cryptography is necessary anyway on the client.
So yeah, so you're saying with Pixie we also need crypto. You're right, but compare the crypto you need to generate a random number and a hash to things like RSA signature validation and these things.
Okay.
Yeah.
Still just limited.
Yes, and actually there's another thing I haven't mentioned yet. The W3C has this thing called web crypto that was in the works for a long time, but the idea was to basically bake in cryptographic primitives into browsers themselves, so you don't have to use these weird JavaScript implementations of SHA-256 anymore. So you know, I think telling the client to do a simple hash is okay. Knowing how much crypto is involved in a full hybrid flow implementation, it's much easier. Okay, but yeah, but the main thing that people really like about it is that it's actually the server taking care of that, and the client can make mistakes. Yeah. Okay. Any other question? Good. Then thanks for your time and enjoy the rest of the day. Thank you.